Hello and welcome to this part one of the recorded demo series on continuous scalable testing in enterprise DevOps, a modern next-gen containers-based approach to testing. Okay, so what are we going to see in this brief introductory session is that role of testing in DevOps. Here is the agenda. What are the continuous testing imperatives out there? Enterprise DevOps quest or FAQs. What common questions the leaders are asking? And then coming to the demo aspect, so solution highlights, and then contents and organization of chapters. What are we going to see in the rest of the demo series? And then the target audience and the key takeaways. So role of testing in enterprise DevOps. So there are a lot of discussions and white papers and published content on this topic. I mean, you can go and check out there. So I have just tried to get the gist out of that in some few diagrams that I'm showing here, right? So what as a message that we get from all these blogs and contents and white papers and discussions out there is that the testing is the core part or a core part of the DevOps lifecycle. So that's what we see here, that continuous testing is the demand from DevOps. And as we see in the second diagram here, so the continuous testing is an integral part of the DevOps. And here in the third diagram, what we see is development, testing, and operations. This is what the Dev Test Ops is a uh, interpretation of the life cycle or the core components of this DevOps life cycle. Okay, so just I have tried to explain through the diagrams the message out there. Okay, so now coming to continuous testing imperatives. What are the continuous testing imperatives? What is the expectation out there um, from the software engineering organizations? So on testing, right? Fully automated testing, the continuous testing delivered at scale and cost effective manner. So this is the expectation. And test reports and results, live dashboards are available like news to developers, scrum masters, other stakeholders, release and operation teams. So at any given point in time, okay, a DevOps team should be able to report the test results. That's then becoming an expectation. And then scalable testing, integrated test data management, virtualization, mocks, stubs, everything enabled, and an end-to-end testing uh, should become a reality, right? So that's the expectation. No infrastructure constraints to testing activities, like scalable testing using containers, leverage cloud platforms, but there should not be any constraints around infrastructure or environment for testing. All types of testing is offered as automated, like GUI, API, unit testing, contract testing, performance, security, load, endurance. What's out there, right? So everything needs to be automated. That's another expectation out there. And test automation architecture frameworks are modern and seamlessly integrated to application development ecosystem tools and technologies, right? So they don't want in the past, if you remember, we used to have separate testing technologies like HPALM we used to have, and then UFT, and developers are not aware of these technologies, so testing team used to use different set of technologies and COTS products, commercial products, and all that. But now more or less the expectation is the testing team also uses the testing team members of in the DevOps team, they also leverage the same technology or same methodology what developers are using. So that way it becomes seamless, and there is no hurdles between the teams in terms of technologies. Okay, and artificial intelligence and machine learning techniques are applied to software testing and development and delivery methodologies. So that's also becoming more or less a next gen imperative there. All testing activities are conducted not in silos, tightly integrated into CI/CD DevOps pipelines, right? So anything you run it in an automated way. They don't want a person to sit there and click a button. Instead, it should be triggered from the pipeline. So that's another expectation. And then SDET, last but not the least, SDET engineers, software development engineers in test, right, so are adaptable to full stack engineers and able to support build, release, and deployment activities. So this is a very important thing that is expected out there, that test engineers are their skills are not just used for testing, but they are also be capable of helping in build, release, and deployment activities, if not lead those things. Okay. So so just we reviewed the continuous testing imperatives out there. Right? This is a vast set of expectations that are coherent to each other, and this is this is just and again a diagrammatic representation of the same thing. So what we see here is ultimately what is the expectation. It's people, process, and tools, technology. That's the same thing out there. And the excellence, or we used to have testing center of excellence, right? So that's the same. You can say that excellence in DevOps. Okay. And then one another important thing that we can infer from this diagram, it's self-explanatory, I will not spend time in explaining that, but is that there's a shift left model also out there. So what does it say? That do more of testing early, which we have been telling from long time. So that's more or less becoming imperative in DevOps world, where you try to run automated test suites in pipeline much early in the life cycle, rather than piling up all the testing towards end, so that you find issues early and fix them. So here are some of the common DevOps, enterprise DevOps quest or FAQs that commonly what enterprise DevOps leaders are asking, right? So I'll just read out them, and self-understanding. It is self-understandable. So I have 10,000 plus regression test cases automated now. How do I run them for developers? So in the previous generation, if you see, right, I mean, in a couple of years back, people were all busy with automating. Now that they have already automated, most of them have automated the test cases. So now where do they go next? Right? What is the next gen solution? How do I run this? So the challenge currently they have is for a particular release, okay, the window is very small, and for running the test, and then within the test they have to run a large number of automated tests. Otherwise, whatever they have automated is not giving them all the results, right? So they're not able to leverage automation into the life cycle, into the release life cycle. So that's one of the thing, right? So next, how do I scale my test runs? How do I keep my cost under control? So I cannot say that I want to run 10,000 tests and I cannot order about 100 servers, right? So we still, it should need, the cost needs to be under control. So where do I run these tests in parallel, right? So how to automate the test environment provisioning to run these tests. What if my application is not accessible in the cloud but internal for security reasons? Can I still scale my tests? These are some of the questions that we get answered through this solution, and also to this demo, and also as an answer to these questions. At the same time, and it's good to review the expectations out there. I know there is a AWS Cloud, Azure, GCP, Google Cloud Platform, but is it really needed to scale my functional test runs? So that's how do I make, because cloud comes with a cost, right? How do I make my estate engineers as full stack engineers? How can I enable developers to run and maintain automated test suites, run unit tests, contract tests, likewise, and like forth, right? So these are some of the questions or common FAQs that all the DevOps leaders have on testing that we just reviewed. So that brings me to this last topic on this before we move on to the solution demo highlights. So how does the this is a visual representation, I don't explain much here, of automated CI/CD continuous testing pipeline. So this is the vision that is realized by implementing this solution. So automation and orchestration of continuous testing, CI/CD pipeline. How testing is, you can see in this diagram that automated unit testing, automated functional testing, automated process testing, automated performance testing, everything at each stage they want an automated testing, and everything seamlessly built into and orchestrated into a continuous delivery pipeline. Okay, so that's the kind of vision or expectation of enterprise DevOps and testing. Okay, so with that, I kind of conclude on uh, uh, the expectations out there, right? So now, what is the answer to these expectations? What is the solution bringing into the table? So that's what we will focus in remaining part of this introductory session. Okay, so the demo solution highlights. So this solution of continuous testing using container based infrastructure is cloud agnostic. So we are not, there are a couple of solutions which are, which talk about, a solution built on AWS cloud or Azure or any other platform. But this solution can be implemented on premise or on any of the cloud platform, or on hybrid or multi cloud, or even on a PaaS based, like platform as a service platform, like OpenShift, or like Pivotal Cloud Foundry, or anything like that. Okay, so the demo solution is built from scratch using Docker containers. There are no software plugin installations that is needed, which you will see, and then there are no admin elevated permissions demanded. So particularly we have I have given attention into these aspects while building the solution, because it removes the barriers on, we know how difficult it is in an enterprise environment where we have to, all the solution works in our lab, and when we try to kind of implement it in an enterprise environment, there are a lot of challenges with the, we have to deal with the enterprise IT departments in order to get permissions to install any piece of software, right? And avoids so this solution takes that into consideration, and it avoids all the hurdles of tedious approvals cycles to implement this solution. So this makes it easy to lift and shift the solution in any enterprise environment. That has been taken care of. Okay, so thirdly, absolutely no overhead. So I have done some comparisons of how does it, like, when you run the same automation framework or the scripts it locally, and then when you run it through CI/CD pipeline using all these infrastructure, when you build this solution out, so it runs very fast, it's easily portable, and there is no any overhead time or delays that add up into this test runs. Okay, so if the test is slow, then it is going to be slow. If your test is fast, automation suite is fast. Once you build it into this pipeline, it is going to be as fast as it was before. Okay, the solution is optimized for infrastructure usage and size. What do I mean here is that, the enterprise, the entire setup can be brought up only during the testing, the infrastructure, and then tear down after testing. So we are built this solution using the disposable infrastructure, which you will see. Okay, so that there is absolutely no overhead of infrastructure that is sitting out there when no tests are run. So we just bring up the infrastructure, a disposable infrastructure, that's what we call, and then we run the test and we tear it down. Okay, so it's an optimized usage of infrastructure. Thirdly, it is fourthly, it is like open source based solution. No commercial tools, technologies, or any IPs plugins is used in this. However, if you have something that is that you already out have it, it can be integrated, and it can continue to support in this solution. But as such, we are not making anything necessary in order to develop this solution out there. Okay, so it is highly cost effective, and this solution can be adopted from any current maturity level and implemented from there upwards. So what do I mean from this is, it is a containerized pipeline that we are trying to run. But if you already have a Jenkins pipeline which is built using your Maven and Selenium grid infrastructure, you can introduce the Dockers into this equation, and you can scale further, to the next generation testing. So it's not like you have to start everything from ground. So if you are at some maturity level already, then you can adopt and go high. So scalable testing solution demonstrated for this is demonstrated for GUI test automation particularly, but the same, needless to say that the same solution can be extended for API test automation or end-to-end testing or any other kind of testing, which is built on similar technologies. So this is very well suited for agile delivery, and for in the end a process that is followed in the integrated DevOps teams. So if you inherit this solution, and if you are continuously delivering this solution, and then on a it is easy to update the progress and what are the activities that are there seamlessly, in your agile meetings, and as part of the agile pod teams. It integrates very well with it. Okay, So that's what I wanted to say. And then this demo is Selenium and Java based test automation framework, but it can also be refactored or modulated to kind of adapted for Python or Node.js or Microsoft VB .NET framework built technologies in a similar way. Okay. So that was an important topic that we discussed on the what are the demo solution highlights. So just to set a very flat expectations on the demo or on that solution, so secondly, I come to the topics. So all the topics are we are in part one now. So there are another five parts. Sorry, six parts where it's all action and basically how we have built this demo is that first we explain a concept and then we perform an live action and we see the live demo and then we review the outcome of that live actions and and then finally we analyze and we move on to the next topic. So that's how it has been organized overall. So in part two, what we see is introduction to the sample application. We start from a sample application and then some one or two test cases and the demo test cases and then the automation framework that is built in order to automate those test cases. So in part three, we will see Selenium remote grid configuration and disposable infrastructure spun up using Docker containers. Part four will focus on package automation scripts like a Java app and containerize the entire solution to run from anywhere. So that's how you go on building this stack. Okay, so that's why it is very important to follow this order and also not to skip any of the sessions, and if you jump you may not understand unless you have already implemented that. Okay, so part 5 will be like run scalable automation test suite, what you built in part 4, right, using containers at scale and publish the test results. So even though that is another question that's out there. So okay, that's okay that I run all my tests in containers, but how do I get the test results? Because once your infrastructure is trashed after the test, your containers are all gone. Where are my test results, right? So we will see how we can do volume mapping and we can get those test results out saved every time when the test runs. So results are not trashed, only the environment and the rest the run logs and all those kind of things are like on disposable infrastructure, but what we want, we have particularly get it out after the testing. Okay, and then set up Jenkins pipeline jobs that you will see in part 6, and integrate code with Git repository. So put all your code in Git and then set up a continuous delivery pipeline Jenkins job. And part 8 is basically execute tests from Jenkins. There's no part 7. Execute tests from Jenkins and collect test results. So that's the end state, and we will conclude with summarizing all the aspects that we saw in this demo series, and and how to exactly come step by step implementing this solution. So that's the end of it. And target audience and key takeaways. So this is for DevOps architects, test automation architects, estate engineers, developers mainly. And then even there is suppose I am a director, I am a business manager, right? I am a pre-sales solution consultant, scrum master. Still you will learn something. There is something for everybody to learn for sure. And technology skill sets that are used is basically Java, Selenium, TestNG, Maven, Page Object Model, Jenkins pipeline, Git, Docker, Selenium Grid, Remote WebDriver, parallel testing, YAML, Linux. Fundamentals or commands are also important here that you will see in the demo. And then the prerequisites, what do we expect is that this is all that is kind of the technology landscape that is used within the demo, but prerequisites to this is this it's good to have a test automation basics and also the Docker container basics. Okay, so with that I will conclude this introductory session of part 1 of this demo series and welcome you to the rest of the part series of this demo, where we will see everything, technical, it's involved in technical deep dive sessions, and built on this framework of concept, action, outcome, and analysis. Okay, thanks and welcome again.